Yeah, overall, thank you again. IONET basically is building a new network that actually allows people to rent out their GPUs for distributed computing specifically, and for whoever need cluster of 100 GPU or 200 GPU and plus. And our technology is the only one technology on the planet that's ready, that can cluster 1 million GPU from all across the globe in one single cluster, and can serve machine learning models with all the current libraries. It's built on top of Ray, which is a distributed computing library that was used by OpenAI to train the GPT models. So it's already enterprise ready and scalable beyond what we can imagine, or there's any available supply actually to test it. Overall, we are like really close to launch. What we like, our unique thing is what we allow is for like multiple things. First of all, people can rent GPUs per hour, and that's the normal cloud experience, but rather the GPU coming from centralized cloud providers. It's coming from Filecoin SPs, RenderCoin, GPU providers, and multiple other providers, all connected to the IONET. And so the first thing is you could earn, these SPs can earn, whoever joined earn whenever their GPUs can be rented per hour, and the agent that's installed on your machine actually doesn't interfere with the Filecoin. So you could continue doing like all the Filecoin things you're doing on your machine, but still, whenever there's no ceiling that's happening on your GPU, it could still serve for like it could be hired per hour. Other than that, because you guys have a lot of storage, you're actually the best on the planet compared even to data centers, the best infrastructure that could deploy, that could host serverless models. All this serverless model deployment, basically they need a lot of storage to store all these models. And then when someone wants to inference a model, it has to boot up really quickly, and then it will start serving the model. And then the owner of the GPU could be paid per inference. Now, this is actually a real problem even data centers are facing, because when they built their infrastructure, they weren't thinking that each one who's going to come would like 4 or 5 terabytes of storage just to put models, and whenever he needs it, he will come back. So the infrastructure wasn't yet ready. So a lot of cloud providers are already like upgrading their infrastructure to have more storage, for more models to be hosted on these storages, whenever you create like a snapshot of your device or so on. And because of these models, there will be currently in Hugging Face, there's more than 300,000 model. So, and we have just scratched the surface of how much or how many models there will be on existence. From now to 5 years, I guess there will be, I don't know, more than like 200 million model at least. And some of these models would actually have millions of users using these models. So we need more storage and we need more compute. Whatever compute you bring is like, you could host 50 million models somewhere, but how are you going to handle 10 million users using that one model? So whatever GPU supply there is, it will never be enough. And the beauty about this model inference is the people who are heading to higher GPUs like H100 or the A100, they usually like hire it per hour. Now, all the demand is going there. But if you look at the model inference, actually it doesn't matter where the GPU or what's the type of the GPU. What really matters is the inference. Whenever like I send an inference to the model, I want to get the result back. That's what really matters to the end user. What's the latency to get the result back of whatever model I would like to deploy. It doesn't matter if this model was sharded on 100 devices or 10 devices. That's not what really matters for the end user. What really matters is, I'm sending a request, a prompt to the model, it's giving me back the result. That's all that matters, just the latency. So the benefit here is you don't have to have the H100. You just have to have a GPU that have more than 12 gigabytes of VRAM and a lot of storage to host hundreds and thousands of models if you can. The more models you can, then the host, you will be hired more per inference. That's like long story short, and I'm ready for your questions.
Can you go through your product again? I thought that was very helpful this morning to show the selection criteria that you provide to your users.
Yeah, sure. Yeah, so the product you guys seeing is going to be demoed to Uber, OpenAI in the Ray Summit in around like less than a month, like 18 days. And
Hey, just so you know, there it is. Thank you.
yeah, 1 second. Yeah, so it's going to be ready really soon. I could go you through the deployed app, but I think this have like more of the features we have. So basically this is like so this is the home of the user, like this is the IONET cloud. And here, basically you can see transparent live pricing of all the GPUs available in the network. We can have the Apple M2, we can have the AMD, we can have the NVIDIA, and we have two ways of people to actually use us. So they could create clusters, like I can show you in the host app. So I could like create clusters. Usually I could create like Ray clusters, Ludwig clusters, and Kubernetes clusters, and all these are basically could be your machine, like SP machine, the SP's machine. So if I could say like create a new cluster, I have the choice to choose like the host would be Filecoin or a data center, or so it depends where the supply is going to come from. When I say a Filecoin, I mean that this host is going to store a lot of stuff on his machine. I have the permission to store more stuff on the Filecoin machine. And the IO usually is more into like really real compute only. I'll go back through the UI. I think it's cleaner. So here are my running clusters. I could go to one of the cluster pages inside the cluster. Where is it? Sorry. Yeah. So this is an example of a running cluster. Basically, I can see the cluster name, how long it's going to be run, because people they book the cluster for a specific amount of hours, they pay for it upfront, and whatever payment for that cluster is held in escrow. At the end of the cluster age, it will be distributed to the SPs. Now, the cluster has a start and end, and it has some purpose. Connectivity tier is also like what's the speed that all the nodes that are going to be part of this cluster would have, so they could all match. And also connectivity tier affect prices. I'll show you later on. And then you have the engineer have a Visual Studio Code to actually work and play around with this cluster. And the cluster has workers. So workers is like one of your machines. This is one worker, maybe another worker in Tokyo, maybe another worker in France. Like it would be different locations, or I could choose I want workers just from one specific location. Each worker, all this device, if you click on it, you actually go to an explorer, just like Etherscan. So all the workers, whoever were in the network, you can see all their jobs that were ever done, all the clusters they were part of, all the inferences they ever if the network ever uses your machine to inference a model, each prompt you will be paid for it, and also it will be recorded on chain. Now, if I click on the worker, I can see more stuff there, but let me go you through the cluster creation process. So basically you choose the host type, and then you choose the location. You already know the utilization rate, or let's say the pressure of how much supply is busy in a specific location. You just filter the GPUs you want, and you choose the security compliance that applies on the nodes that you're going to rent, and also the connectivity tier. So if you have really high connectivity tier, and that's actually one of the advantages of the Filecoin machines, also they have really high connectivity tier beyond what is actually needed, which gives you really high price. Like the ultra high speed connectivity tier could increase price by 60%, like the price of your one card, your one GPU. Then the client just choose the purpose of what's this cluster, and what happens is after that the network will basically grab all the supply all around, connect it together using what's called the IONET network backend. And this network, basically it's a mesh VPN, and all these nodes from all around the world will be communicating with each other, coordinating tasks. If one of the nodes failed, the network will bring a backup node. There's a lot of things happening, but all this will be ready, will be launched by end of September, and demoed at the Ray Summit. Long story short, yeah. So at the end, the engineer basically have to pay for the cluster. So that's what you're gonna pay. He deploy the cluster, pay for it in advance. The money is held in escrow. At the end, if your worker were up all the time, you won't be slashed. You will be paid your full amount. If you were slashed, you'll be able to claim your rewards less than what you're supposed to be able to claim. Yeah, overall, that's I think the Well, and also we have the Kubernetes cluster, which actually it has to be SOC 2, and the Kubernetes clusters are like, this is like really the high end, and we work it. So basically, you can deploy any app on this network. It's a like fully decentralized network, fully decentralized Kubernetes nodes that, you know, ready for enterprise use case. They could deploy APIs, they could deploy whatever, because of the architecture of the fault tolerance that Ray helps in. It actually make it really robust, and because there's more nodes, and it's harder to fail, I would say. Yeah, I think that would be enough to share the product now, because you guys are the first one to see it.
Hey, Ahmad, I know you're looking for testers right now. Kind of what's the benefit for getting in early as a tester?
Yeah, so that's a good question. I think we're looking into like some kind of a concept of like token giveaway or airdrop, in a way like an investment, where you invest your compute power to test with us, and in return you get part of the IOCoin. You join the IOCoin, and you'll be, you know, like somehow compensated with the IOCoin, and you know, but later on when we launch, you will have higher priority in serving models or and so on. Yeah, so ask if do SPs need to be SOC 2 compliant? No, they don't need. It's just like we're forecasting that if you have SOC 2, you're gonna have massive demand, more than if you don't have SOC 2. The reason is because with SOC 2, other platforms that we're integrated in, we're working on the integration. They want SOC 2 GPUs. Like they don't want their clients to deal or deploy models or whatever on non-SOC 2 compliant GPUs. And they will like label like you're deploying on non-SOC 2, this is unsecure. And this is something that would reduce the demand. So, but that's why we'll have like two choices: SOC 2, non-SOC 2, and price would be like 70 cents or 20 cents because you're not SOC 2 for a specific price. So if you, yeah, I guess I answered that. So it's like 80% more profit at least. Like we're still looking at this, it could actually reach 200-300% more. But currently, I think because we're still not yet deployed and running with them, so it's not yet really clear the exact numbers of this.
Jonathan, go ahead.
So on your platform today, can you tell us what features at work and you're comfortable saying these features work, and then what features are going to come out in the next 6 months that you're also building? I'm trying to just work out where you are on telling the story and real features that actually work.
Yeah, whatever you saw now, this actually was going to be ready by end of September. Even there's some stuff I didn't show you, the Explorer, the worker, there's like the iWorker, it's another dimension, which is like for you as an SP to manage your machines and so on. That's also going to be ready because like iCloud and iWorker are like fully connected. There is other features where, like as I think said at the beginning, what I see the future is, and I can see the demand. It's not the future actually. I'm looking at it right now. At Hugging, there in Hugging Face, there's 300,000 models. Just 3 weeks ago, there were 240,000 models. So the amount of models that are being built is crazy. It's massive. Now the thing is, the owners of these models are unable to actually make money out of these models. So what we're doing is, and if we have like solid SPs joining us, come as an engineer, build your model, host it on the IONET, which is hosted on your on your device, and then you will earn money. Actually, your model is tokenized, and any inference on the model has to be through the token. And actually, if you look at the current models, this serverless model deployment, they actually charge you per tokens. Like if you look anywhere, they have tokens per like inference weight and so on. So the concept of tokens on inference is already there. It's already there. It's happening, but they're just using the word token, and they're just putting it in a bill in a way. So tokenizing these models and then hosting them on the SP's machines, and then allowing the people, the other users, to actually access these models anytime they want for inference. So what is coming as you said, what is coming is a massive inference platform which has thousands of models. All these models are ready to be booted up in milliseconds because they're already hosted on your device. And once they boot up, anyone who would like to inference the model, they can inference the model, and you will be paid peer inference.
Cool. Last question. We can get paid in dollars, right?
USDC. Yeah.
Okay, cool.
How much demand do you project to have at launch? And then how do you see that demand growing over your first 6 months, 12 months period?
I can't give the numbers. I really don't know. I mean, we've been talking with high-end enterprise level platforms that are providing LLM training and so on, and we are already working on the integration with their platform. It's a big one. The company spun out of Uber. We don't know how much is the demand. We really don't know. But what we know is like one client, we talked to one person, I was like, yeah, we want 10,000 GPU. And then another guy we talked to, like, we want 40,000 RTX 4090 SOC 2. And then another guy, so like all the people we're talking with in SF, they're crazy. They want a lot of GPUs, but they also wanted SOC 2. And that's why we had to like move a bit in the way where like, okay, we're taking the demand, whoever wants to train some models, play around with LLMs, build his own LLM, deploy LLM, inference, whatever model he would like. Yeah, we built all that. But we can see that there's really big need for a lot of GPUs. And that's why we wanted to build a platform that could, earn their trust from an infrastructure perspective. And also Filecoin reputation as of it's really huge project. So when we say like, yeah, you could also use Filecoin to store your model data, your ML flow data, and all that. You could build a vector DB and store it on top of Filecoin. There's a lot of like, good things that merge between data and compute, right? So we're trying to take the compute, and you guys have the storage. It's really good, collaboration on this. But as of how much demand, I really don't know.
Can I ask another question?
Go for it.
So I understand the market today. I understand that there's going to be more models, and it's good that we need to host them and we can run the compute. How did you get to this point? Because ultimately, there's a lot of engineering that needs to happen just to get to this point. Like, did you? Who built it? How did you get here? And just walk us through that, if that's possible.
Yeah. Well, yeah, I mean, that's what we've been doing for the last few months. Mainly, so what I was doing before I started this project, I was building a low latency trading algorithm that it's a quant fund, and we basically had to like build a new model, pre-market on the US market and on crypto, but mainly most of the heavy load was on the US market. So pre-market, the model starts to aggregate all the tick data, like tick by tick, whatever happening in the market, and then start to train and find some specific patterns when institutions fill orders and bots start to trade. And this model, starts then, and then after that, this model have to, once it's good and it's good prediction, it's making good predictions, it keeps fine tuning itself while the market is going tick by tick, and then it starts to trade. And it has to send trade execution on 30,000 account. All that should happen in less than 200 milliseconds. So building such thing, I had to go through distributed computing and use a lot of GPUs. But like the bill was like 70,000 a month. And basically building that systems and that complex architecture, in the end, it's just like it became like just model inference model. It became so easy. Now the architecture just yes, sorry. So the architecture for that helped me. In the end, I reached to what's called Ray. So Ray Summit, and that's where we're launching, is the main protocol we're built on. So we're using Ray framework, which allows distributed computing, which is currently being used by OpenAI to distribute the inference of the GPT model for all the millions of users they have. The Ray framework is the most robust distributed computing framework on the planet. And like we believe in the Ray community, we support the Ray community, and we contribute to the Ray And we're sponsoring the Ray Summit along with Intel, Databricks, and AWS. So like all OpenAI team is going to be in Ray, like all in the Ray Summit. All the Uber, Instacart, thousands of models are being deployed, for example, by Instacart, thousands of models, and all of them uses Ray. So this architecture already there. So we took that architecture, we improved it specifically for the AMD GPUs. And we're actually kind of building a full protocol on top of Ray. So imagine like this Ray distributed computing as a protocol. That's what we're building right now. So yeah, we're getting there, and we're not really far actually. We already have a demos. We're already playing with it. We're just trying to we're trying actually to solve the problem of how can we have 300,000 model on the network. Like how could we, store such massive size of models? And this is not. It's just the beginning. Like what this model is going to be, it's not 300,000 model. It's actually 300,000 model, but then you need to replicate the model on a lot of devices when there's more inference. So if now there's 300,000 model, we basically kind of have, because they're replicated, we can have like 4, 5, 7 million models at least. Now, this 7 million copy of the model, and this is just, when you don't have a lot of users. Imagine after 5 years, when there's every app on the planet uses a model somehow, who gonna store and who gonna compute the inference for this model? So that's where we see the future there. Like we started like LS over clusters and hour and so on. But then when we got deeper, I was like, there's a big problem here and actually a big opportunity. So yeah, that's why we moved to we got into this inference thing.
Okay, perfect. Thank you.
Yeah, anytime. I think David here has a question.
Yeah, yeah. By the way, I reached out to you. Would love to participate in your beta. Do you know when you're going to have like a working demo? I mean, I think you took us through some Figma pages, but it would be cool to actually see one model working. I know we're talking about 7 million here, but this is a pretty difficult problem to solve in terms of distributed computing against different GPUs. So curious to see if you've been able to end-to-end demo that for anyone.
Yeah, I can demo it to you in private. Also,
great.
if you're coming to Singapore PhilDev Summit, I will be there, or Vegas, I'll also be there. But anyway, the platform will be ready for at least I could send you an invite to test it yourself mid to end September.
Great.
Angela, go ahead. You were next.
Hi, I was just curious what would be the best way to get in touch with you if you want to talk more?
Yeah, Shadid at io.net. Send it in the chat.
Perfect, thanks.
Jonathan, you have another question?
No, sorry, I left it down.
Okay, I guess this is it for today.
Well, have a great morning, Ahmad. Thanks for joining. Please reach out to his email address here in the chat if you'd like to learn more or participate in the pilot.
Take care, everyone. Bye-bye.
Thank you. All right, and with that, time is up. Have a great week. Register for Phil Vegas. Sign up for Dev Summit, and hopefully we'll see you at both of them. Thanks, everyone.
Thanks, Porter. Thanks, all. Thanks, everyone.
So you shared a lot in a short amount of time, but try to come back and what's the TLDR, like too long don't read, for storage providers on what's in it for them? Why, help just kind of re-summarize that point, and then we'll open it up for questions.
Right. So there's two phases here. There's the testing before we launch, and there's the after launch. If we talk at the phase one, whoever joins at the phase one, they will basically have the highest priority whenever we launch to provide the inference or to provide the compute power per hour. That's first. So what is in it for them to be pre-launch is basically equity and token warrant at the current valuation of the current round that we're raising. That's what's in it for them. So we could evaluate your compute power. If you have 100 GPU or 1,000 GPU, could evaluate it as at like 2 million a year, and then we will give you equity and warrant and tokens for that, because for the IO token. Now the phase 2, which is when we actually launch, if you decide to join at that phase, basically we're talking about 100x more profit per hour if your machine is hired for in a cluster as a Kubernetes cluster, or is hired to serve an LLM model at massive scale. Plus you actually have you will be also paid per inference. If you have big storage that's available, we can store like 300-400 models from Hugging Face, the top wanted models on your machine. Whenever anyone inference any of these models, you're going to be paid per inference, like a microtransaction. So think of it like you're gonna have an income every 200-400 milliseconds. So both of this together, I think this is what we're offering right now.
Final question on my end, then I'll open it up to the group. When the product goes live, how do you forecast or predict what kind of client usage or pipeline you're going to drive at launch or within the 6 months or a year?
Yeah. Well, looking really at the industry, I think the LLM thing is going bananas. It's really going crazy. And we mainly currently focused on distributed LLM inferencing rather than training. There is massive network overhead for machines for training. That's why they, using the NVLink and all this complex networking infrastructure on the GPUs in the data centers. But for inference, actually, it's much more better. It's actually better to use it in the way we are doing it right now, because the GPUs are distributed across the planet, and the models could be closer to the end user. So the inference time is even less than how much would it take in data center.
All right, we got the first question from the chat. What percentage of the time is a GPU transferring data to and from the host versus the time spent crunching a data set? Or is it a continuous flow?
I didn't get it. Could you, or maybe I could read it somewhere?
It's in the chat.
Is the GPU transferring data to and from the host versus the time spent crunching the data set? Well, that's a good question. And that's why the Filecoin SPs have an advantage here, because basically they will mainly, I would say 70 to 80% serve models that already exist on their hardware, because they have a lot of storage. So when someone hire their GPUs, they don't have to download the model whenever they want to start using the GPU. The model is already there because there's massive storage. So imagine the top 300 models across 3,000 GPUs on the Filecoin SPs. These models could be used for tensor parallelism for people to, if the model is too big for your GPU, there's other GPUs that already have the same model, and they could come together, and there's a batcher that actually takes a little bit from your model, from that model, and from that model, and then the network take cares of payment for each one whenever we use the model that's hosted on your GPU, on your hardware.
A couple more questions that I'll read out. What models of GPU is IO.net interested in renting?
Anything that is basically any GPU, but as long as it's RTX 3090 and better. So we look at it in terms of memory. If you have 12 gigabyte of VRAM in the GPU, and that's mainly what we, so 12 gigabyte of the GPU and the RAM, it's the T-flops are more than 30, which is basically RTX 3090 and better. And you have storage more than 5 terabytes. That's free. So if you have all that, you're a perfect candidate to join the network.
All right, I'm gonna just go to this chat and go through them.
Yeah, there's a question of estimated price to rent a GPU per hour. So look at it this way: if you have an RTX 3090, you're gonna earn per hour. Let's not talk about inference. You're gonna earn per hour more than 40 to 50 cents. So if your utilization rate is like 40 to 50% a day, we're talking about like $5-6 a day in a way, or higher or less, and that's already massive. Like if you use that RTX to mine, you wouldn't make more than 40 to 50 cents a day. So if that's one thing, but the inference part, it's maybe a bit more complex to explain by words, but it's actually much more profitable to the machine, because you're having basically the price is 4 or 5 times this 40 cents an hour for pure inference. But it's again calculated at the second level. Yep, that's it.
You want to keep going through the chat questions?
Yeah, there's one regarding security. I think, again, one thing that actually gives an advantage to the SPs is that the infrastructure, first of all, they have the best internet bandwidth. They have almost the most secure, almost near to the data center security. So they're more secure, they have more storage, they have, and they're very technical, the community, so they can understand, the setup part. And also from a security perspective, and in general, it's not a consumer GPU at home, and that's not what we were like going for. It's a GPU that's mostly hosted in a data center level location. So that gives a massive advantage to whoever want to rent GPUs coming from Filecoin. They will actually, be more. They will feel more safe for the data. There was some discussion with one of the big 4 companies regarding giving, verifiable credentials for SOC 2, and it was with the, with Protocol Labs team. So, there's other things we're discussing in security, but for now, I think this is what I could share.
You're on a roll, Ahmad. Keep going.
Is there any more question?
Yeah, so is this a car native? In other words, can it read our data model?
I don't understand this question, honestly.
So, Bob, do you want to jump in here? This is your question.
Yeah, I'm already discussing with Reba, who calls me out on it. So, so the reason why is that so our data model, so our structure is in car files, etc., and it's not like you feed just data into your AI or ML model. You have to be aware of how the data is collected in a Filecoin storage provider setup. That's what I'm asking about.
Oh yeah, so if we talk about like storing the machine, so basically what we do is, meaningful, everything runs in Docker containers. So basically you can know the level of security that we are exposing to your machine. We don't have access to your file system, but we only have access to one file which will store the models. So it should be just a normal file, and it's usually mounted to the main container that's running all the services. And the more model, sorry, just a second. Yeah, so this file will have like 100 model, 200 model, and that's all what the system can read, because everything is contained in the container. So if there's any security breach or whatever, there's no access to your host terminal, or there's no access to any other file system than the folder that have all the models inside it.
Jan, you want to chime in with your question?
Correct. Yeah, I was wondering how is your product deploying to like the end users, or at least the other infrastructures that you're talking about? Like you mentioned there's a lot of GPUs around, right? But how is the control plane going to control like the orchestration of different trainings on different data centers? Just for a start.
Yeah, so I would like you to think of us as the kayak in a way for all the GPU suppliers on the planet in a way. So if anyone have a GPU infrastructure, or like, whatever, someone have GPU that's not used in a data center, or someone who's already providing GPU in a data center, basically we connect to more than 500 data center, and all these data centers, they are priced, they could have their own price. And basically, this whole network aggregates all these GPUs and gives priority based on like uptime, reliability, basically reliability of the machine to inference models and so on. So there's a scoring mechanism inside. Someone asked also like how could we differentiate from Jensen AI or Akash? I think what's really important is, like, we have to understand the concept of distributed computing. Going and renting one GPU is something that, there's vast AI. You could go just literally vast.ai. You could rent one GPU from someone, but that's not what we do. We actually don't offer 1 or 2 or 5 GPUs. We only give people cluster of GPUs, and it's actually in 3 buttons in the UI. Like, create a GPU. We only create clusters. So clusters are like 100 GPU and more, and these GPUs should not be in one place. They could be like one in Tokyo, one in Japan, one in US, one different locations, but they become a cluster. And then they act like a one. When you connect your runs distributedly, so all the code is actually distributed across all your cluster, and you don't have to worry about fault tolerance and so on. So if you look at, for example, Jensen AI, they basically look at they try to calculate the compute and then send the compute job to someone to calculate and verify the compute. That's what we do. We're not to do that. We're just trying to give the same cloud experience anyone could have on AWS or any GPU provider, but the GPUs that coming from here are actually not GPUs for in one data anywhere else. That's the thing. The other thing is the cluster thing. We focus specifically on those who want distributed computing, and who needs distributed computing is anyone who needs hundreds of GPUs for mass. Yeah, so if you look actually at the cloud, basically, you know, the way it works is, just a second, sorry. So you create clusters. You have like Ray clusters and Kubernetes cluster. If you go to that process, you see you have the Filecoin. The host type come from Filecoin means they have massive models stored there. And then basically you just select where are the GPUs you want. You want different, whatever locations of GPUs we have available, you'll be able to select multiple locations. So maybe closer to your end user. And then you just choose the model type. There's even the M2 chips from MacBooks. And the quantity, there's permissionless, no limitation, no quotas. People can rent literally the whole network in a cluster. And then, you know, they could choose the security compliance applied to them, but also there's the connectivity tier. So I could choose like, I want only like medium speed GPUs, like their internet is fast, or ultra high speed, and prices actually affect that. Security compliance on the GPUs affect that. The connectivity affects prices, and also the you know, the more services like PyTorch, FSDP are more expensive than Ray or Ludwig. And then at the end, the engineer just, you know, select the quantity and basically just deploy the cluster. That's it. In 10 seconds, the GPUs will be given to him in a cluster, and then he have a Visual Studio Code to play with it. And it's not one GPU. Again, it's hundreds of GPUs or 1,000 GPU, and then you just put it in your Python code. And we use Ray. So Ray, we're built on top of Ray, and Ray basically is the infrastructure that actually, I'll show you, that actually powers the ChatGPT inference. And even Ray was used for ChatGPT to train the model on 300,000 CPU and 20,000 GPU. So we're on top of the Ray architecture, and Ray allows us to do that. You could read more about Ray. And the infrastructure is used by like almost everyone who's big in the industry. And we're already speakers in the Ray Summit, and we will be launching there. And if you look at us, like we are golden sponsor with like IONET is gold sponsor with Intel and other providers. Sorry, my internet is not so good here. And like we will have that exposure in the Ray Summit. The infrastructure is built on Ray. Ray default terms is crazy, and the users of Ray, whoever needs massive quantity of GPUs distributed across multiple cloud providers for massive long training or for a lot like really heavy inference tasks. So basically, we're bringing the best distributed computing infrastructure on the planet. We're putting that in a decentralized network that connects with multiple providers like Filecoin or Render or other machines, and then aggregate all this into a unified API for people to, you know, inference models, host models, and train whatever they want to train. And prices or security, everyone knows beforehand what is this security I'm risking, or what is the connectivity tier I'm renting. So there's a lot of, you know, layers that makes the experience so easy for the end user. I took too long time.
I got a couple questions. Do you want to jump in?
Oh yeah, I was just wondering how you can ensure those speeds. Because now I liked your screenshot there, if you don't mind going back to that, because what you're actually showing are the user selection criteria, right? And so
Yeah.
those are really crucial for us. I took a quick screenshot, if you didn't, just to like, so one is the network connectivity, two is the SOC 2, and there was end-to-end encryption as well. I saw. What is that? Is that encryption provided by you, or is that specific requirement that you push back on the underlying provider?
Yeah. No. Well. Yeah. This is basically all of the machines are like we're really doing like an extremely complex way. In any way, if anyone would like to hack the data that's being processed on the GPUs, this is currently like a problem that only homomorphic encryption could solve it. But with the benefit of distributing the data, you can literally like shard the data to small shards on a lot of GPUs. That if you get just small of it, there's no way you can actually make sense of it. It makes no sense. Even the model itself, the weights and the graphs and all that, it's also distributed, but also end-to-end encrypted by default for everyone. Like the whole infrastructure for us is end-to-end encrypted. We are doing like penetration testing on it. It's really hard to hack it, really hard. Like you need the best engineer on the planet who can hack the memory of the GPU to somehow get something out of it. But for SOC 2 also, these are like, if it's a data center, basically he's by default SOC 2. And we have the discussion with one of the largest companies before, with the protocol lab teams, to how could we provide this verifiable, blockchain verifiable credential that this SP is SOC 2 compliant. And when he's SOC 2 compliant, it means there will be a lot of traffic coming from enterprise users.
Yeah, no, I'm actually asking the question. I know we've talked before, but I'm actually asking the question because I want the storage providers that are on this call to understand what is required from them to be able to participate in this economy.
Nothing.
Nothing. Just to step back, the SOC 2 is not that's something they need to provide. That's something they need to be qualified for. They need to certify themselves, right? Because
yes.
Right now we have very few SPs in our ecosystem that are SOC 2 compliant. This would be a reason for them to transition if the revenue, right, is sort of like there. And so you were making some comments earlier, like, yeah, you can make X amount of dollars. Maybe can you explain that again? Like what actually is the opportunity? You said 50
so the
cents
opportunity. Yeah, so the opportunity for SOC 2 is the following. So we have a massive LLM platform, really massive partner that is being used by Tencent and the top companies on the planet right now in SF. That this company is actually spun out of Uber. And these guys, they currently have, like, you build models without actually writing code. It's really a huge platform. And it's so easy, beautiful. You can build your own LLM without writing any line of code. You just basically plug the data. And we actually, in there, we have, as data, to store data, we have Filecoin as a choice inside their platform. We integrating that with them. So engineers could store all their LLM or the ML flow data into Filecoin for extremely, like, we're trying to make an alternative for S3. Now, after they choose the data they want to train the model and fine tune it, and then they have to choose where are you going to deploy the training workers. And there they have AWS, Google Cloud, and there will be IONET. Now, the clients and the users of that platform, SOC 2 is critical to them. It's like you have to train on SOC 2 because the data is extremely important and sensitive. So then these clients, the big guys who are going to pay per inference, $50,000 a day, or for training much more, they would they want more GPUs, and that we're bringing, but also they want more secure GPUs. So if we could verify that these GPUs that are SOC 2, when they deploy on that platform, they have SOC 2 GPUs, not SOC 2 GPUs. So SOC 2 GPU is the same GPU. For SOC 2 is 70 cents. If it's not SOC 2, it will be 30 cents or 25 cents. So if you upgrade to SOC 2 later on, after there's more traffic on the network, you will see the economical benefit of having your infrastructure SOC 2 certified. But it's not needed to be done now. Also, upgrading your connectivity also increases price by 20% to 40% if it's like plus 5 gigabits of download and upload.
That's awesome. Yeah, that's all good information. So you're saying, like, actually you could get started even if you're not SOC 2 compliant today. It's probably, like you said, it's going to be 30% of what you could make when you are SOC 2 compliant. Sounds like, that's good. Thank you. Any requests to the community here on how to test or integrate with your stack and how we can get this off the ground?
You mean for the SOC 2 part or for the other thing?
Oh, no, in general.
Just normally.
In general, like, yeah.
Yeah, in general, yeah. I mean, they could reach me out an email. We could create a like a Filecoin Slack channel specifically for that discussions. But we're looking to have like 5 to 6 SPs who could join us in this closed testing, and whoever will join us, you know, we'll talk more in another call maybe on the benefits of that. As I mentioned before, there's the phase before launch and the phase after launch. So for now, like I'm just like letting you know there's something big coming, and looking forward to work together on this.
We had Dinesh, you want to ask your question? I think it's a good question to go out on.
Yeah. Hey, yeah, good stuff, Ahmed. Yeah, I was just trying to understand a bit more about your company and team, where you guys are in terms of, you know, product and funding, and then ultimately, what are your target markets, both on supply and demand side? Are you going after specific pieces, or is it, you know, try a catch-all type approach? Sorry, there's a few bits in there, so I can repeat.
Yeah, nice. Let me get the first one. So because our lead investor have not yet announced regarding funding, so we're not really allowed to talk. But we have like what I could say is Solana is part of our investors, and we have raised money already back in May from like one of the top 3 VCs in the crypto market. Now, the second round is starting already really soon after we launch in the Ray Summit. And like currently we're standing at 57 million valuation. And as if you said, I think the last part, who we are targeting, we at the beginning we were like catch all. If you noticed, we did an RMP render proposal, which actually asked them to expose their APIs so we could take GPUs from their supply. So that was like the initial move. And then, you know, we were like testing multiple grounds, and we found out that if we need GPUs for inference to make it closer to the users, you know, having consumer GPUs is something. But also because we have like, currently I have one client who asked me, bring me RTX 4090, 40,000 of them. And I was like, from where I'm going to bring 40,000 RTX 4090, but also SOC 2. So this hardware is like 60 million worth to actually build it. So that's why, like, this is just what at the beginning. So then we noticed that there's the massive demand, the one who want 40,000 GPU, 20,000 GPU, the massive demand. They want SOC 2. They like, give us SOC 2, make sure it's compliant, it's secure, we are in. But if it's just consumer GPUs, we will use it. But for, you know, for trials, for testing, for that. And then while we're doing that, we noticed going to serverless inference, serverless GPU thing, where you could, like, these models are just deployed in a lot of GPUs, and someone can just expose an endpoint and just inference the model. The demand there is crazy. It's beyond like, so we started as a cloud, having experience like cloud provider, and now we are already adding to the platform when we launch it, the serverless model deployment. And these models, the best place to deploy them is at a Filecoin. And we will have an advantage in the market that no one on the planet has, which is the serverless model. Let's say Llama 2, the model from Facebook. If you want to deploy it anywhere on the planet, you have to pay for 2 things. You have to pay per hour when this model is running and waiting, and then you have to pay per inference. And that's like the cheapest one. They could, you know, decrease prices per hour or whatever. Like, they could play on that, but they can't remove the per hour price because the GPU, the model is running on a GPU that could be rented. For the Filecoin SPs, the model is already on the GPU and the machine is already working. So there's no per hour, there's just per inference. So it would already bring a lot of people, instead of going to this model and just running it per hour plus per inference, all these builders on these models, there's like, why to pay per hour if I could go to the Filecoin machines and they already have the model for free, but I could just pay per inference. It will already decrease their cost by 80 to 70%. So this will give us a massive advantage on taking demand from this serverless model deployment market.
Just to have a follow-up to that, if we have time. So what is your kind of long-term opportunity that you're pursuing? I mean, I understand that there's, you know, this crunch around availability of GPUs globally and prices and so on and so forth, but don't you see that fading over time, or?
Not really. I mean, it's yeah, good question. I want you to imagine this. First of all, I like this IO coin. I really can see this is the $50 billion coin that are gonna gonna be number one for the AI category in coin market cap in the next 5-6 years. Why? It's a good question because we're building a network, but I don't want to get into too much detail. But I want you to imagine the following. Currently in Hugging Face, there's more than 300,000 open source models. These models are, people are just building these models and putting them on Hugging Face for free. Now, you as an ML engineer, if you could build a model right now, what's your incentive? There's no incentive. You could either sell the model somehow to some big company, or you could just put it open source on Hugging Face and maybe get some community around you who will love you, and then you get a job at a big company, or you maybe have some funding, or you're so smart that you could build a startup and build a team around it and raise funds. So there's not really an easy way to earn money from your model. But and just putting this information aside, let's go to one other way. In the future, in the next few years, there will be millions of models, and just like the App Store on Apple, and each one of this model could have millions of users who need this model for some app or for some service. Where are all these models going to be stored? Where are the GPUs are going to provide millions of inferences for one model? Like imagine one model is so good, have a million users that want to use this model because there's an app built on top of it that uses this model. So there's no way at any point of time there will be enough GPU supply to actually cover such demand. Impossible. No one can manufacture this. There's a lot of geopolitical tension in Taiwan and China. There's a lot of problems happening there. And there's no way, not for the next 5 to 6 years, that at any point of time, we will have more GPUs than the demand.
That's great.
Just a question. So you remember the part where you can earn from your model? So you can't earn anyway from the model, but at the IONET, so the network has the IO cloud on top of it, but also it has the IO models. And basically what you do is you build your model, you bring it on the IONET. It will be hosted on the Filecoin machines. And then anyone who would want to build an app to use your model, you as the model owner, you will earn from each inference on your model. So tokenizing models, tokenizing compute power, this is going to be something, in my vision, I think it's going to be big. And we want to test that and try that. That's why we see the Filecoin SPs is a huge opportunity. We're like on just scratching the surface of how big this could be.
Excellent, excellent. Just last question, just to follow on from that. Thank you, Ahmed. So if I kind of simplify AI sort of in the decentralized space, right? So you've got the compute piece, you've got the model piece, and then you've got the data piece. So I can understand that you are allowing compute owners to monetize compute capacity. You're enabling model developers to monetize or incentivize model creation. And then the third piece, which is the data owners themselves, are they also getting paid somehow? What is the model, or are you doing something on the data side as well, or is that?
No, no, this is something we still don't have the capacity to work on. Not the funding, not the team. There's a lot of work need to be done there, and I don't think we can do it right now. So we're leaving this to someone else, Ocean or whoever can handle that. Yeah.
Yeah, I don't think anybody's doing all three pieces. Yeah, that's fantastic. Thank you, Ahmed. Really helpful. Great stuff.
All right, Ahmad. Are we going to see you at the Dev Summit in Singapore?
Yeah, I'll be speaking there. Thank you for the opportunity.
Yes, and I did invite you to Phil Vegas. How's Phil Vegas looking for you?
I'm in.
Yes. All right, so that gives you, everyone on the call, 2 shots. Come meet Ahmad in person. Otherwise, I'm sure he'd be more than happy to accommodate you if you're willing to fly to Southeast Asia and say hello.
Sure.
Ahmad,
Porter, can I answer one?
Yeah, go ahead.
Can I answer one open question so quickly? So Jan asked, is your product sort of Ansible script to deploy Kubernetes on bare metal so they can start using or attaching some of the GPUs for their pods? How's your control plane offloading the inference part to other infrastructure? So basically, the answer to this question is we don't look at the Kubernetes like how to say, there's a head node and there's a worker node. Now, let's forget about the Kubernetes clusters for now. So the head node basically is it's a node that takes all the requests, all the inference requests, and so on. Now the core architecture of that, it uses the Ray distributed computing, and Ray is the packages and all the infrastructure that handles the fault tolerance and also handles the task scheduling based on the compute power available. So Ray itself from inside knows and maps all the machines that are available and what the GPUs in each machine and what's the power and if the machine is busy or not. And basically this head node, sends the request, redirects the inference to that head node. Now, this is just one head node with a lot of workers, and one head node could handle 500,000 machine in a single cluster, and it will coordinate all the tasks between them. You don't have to worry about any of that. Now, there's one layer on top of that is basically a head node and a head node and a head node that are, so I could have a head node and its workers in Spain, and then another one in San Francisco. And there's, it's like a cluster of clusters. And then when the inference comes in, if the user is in San Francisco, it will go directly to the San Francisco cluster. It will inference and it will bring back the result to the San Francisco user. So the machines are closer to the user, or like basically the request goes to the machines that's closer to the user to make the inference and bring it back. I hope that answered the question. And
yeah, when I saw the Ray, I kind of understood the architecture already. So really excited about the product, but I don't want to turn this into like a tech talk. Maybe I'll leave the rest of the questions when I meet you in person in Singapore. There are still some questions that I want to ask. Yeah. I'll send in a chat, but you don't have to answer them. Yep.
Yeah, Jan, this is all we got for the rest of the call. So if you got one, fire away.
Sorry, I can't remember who, but we're saying that if you want to upload a file, it has to be split into car files. So I'm not sure how are you going to put the model, like for example, let's say I want to deploy Alpaca with 65 billion parameters. How do I?
So nice. So basically for that, what we do is, yes, each device have to has the whole model. So, but the device could not like the GPU itself can't put the whole model, like it's 100 gigabyte. How could the GPU handle it if there's only 8 or 12 or 24 gigabyte of storage or VRAM in the GPU? So what happens here is we use tensor parallelism and data parallelism. It's so simple with Ray. Ray is amazing. It will take the right weights or graphs from the model and put it on this GPU with what this GPU could fit. And all the head node does all that and like sends the orders for that. And it will split the model. Like if it's 128 GB, so I need 10 GPUs. So it will do it by itself. It will put the model, and not me. This infrastructure is already built by others, and because ChatGPT is huge, you have to distribute it. You have to put it on tens and thousands of GPUs for big inference. So the infrastructure for Ray already allows you to put tranches of the model sharded on each of the GPU memories, and then there's the batcher, which is the head node itself. It takes care of talking and doing that. Not all the models fit for that, but at least 80% of the LLM models work in such architecture.
All right, final questions from the group, and then that'll be a wrap. So if you have something for Ahmad, now's the time.
Well, obviously, his discussion around how much demand there is due to the AI needs, and the fact that as Filecoin storage providers, we use high-end GPUs. And I believe when asked specifically, he basically said RTX 3090s or better, something with 12 gig of RAM, high performance units. So that was one point. The other point I think he made was the profitability, that these are GPUs are going at a premium. There's sort of a shortage of GPUs. So if we have spare GPUs, there's an opportunity to rent them out, which I think they're still in sort of a beta phase, right? So it's not something that you can get today, but it's something I think they're looking for people who are interested.
Yeah, and on that point, what I did find interesting is that let's say that whatever your GPU rate is, if you're SOC 2 compliant, that rate close to triples.
Yep.
Which I thought was interesting. And I know some of you on the call are pursuing SOC 2 already. And I think it's, you know, it's a lot of effort to go get SOC 2 compliance or ISO compliance, HIPAA compliance. And it's a way to further distinguish yourself in this type of marketplace that I thought was interesting as well. So, ideal case is everyone on this call is SOC 2 compliant, but I know that, that's not probably feasible in the short term, but like a year from now, 2 years from now, what percentage, as we see trends towards more, what's a term I'm looking for? Reputation scoring. SOC 2 is going to be something that would elevate you in a Filecoin reputation scoring, just like it does within this environment as well. And again, if you're sitting on a lot of excess GPUs, perhaps this is a good fit for you. And again, whether you believe in IO.net or not, I do see a number of these types of solutions coming to market, hopefully within the next 6 months. IO.net, for example, is looking for pilot testers now, and they're willing to compensate storage providers who are willing to participate in that testing with some more favorable equity terms. Whereas, you can still participate after GA, but I just don't think you're going to get the same terms as if you come in now. So I think they were targeting a, kind of October 1 launch. And they are going to be at the Dev Summit in Singapore, and they are going to be at Phil Vegas. So if you want to reach out early, let me know. I'd be happy to introduce you. Otherwise, you can wait for the Dev Summit Singapore or Phil Vegas. James, I'm going to pick on you a bit. Anything that you took away from this morning's conversation?
You talking to me, Porter?
The one and only James.
Sorry,
other James.
I actually had to drop right after the 5 minutes in. I'm afraid, so I can't comment. But it does seem like we're getting a couple of these now. Lumino's doing this sort of thing as well, and I know they're going to be at ESPA, so it's good to see.
Yeah, John, I'll pick on you. Any takeaways from this morning?
The thing that impressed me the most was his enthusiasm for seeing the marriage between a high concentration or high density of GPU class resources in conjunction, because we do, with the large data sets for both inference training and in running inference models. And he painted a picture that was very compelling in that the trajectory is that there's going to be lots and lots more inference models that are going to be run ad hoc. And it takes a lot of space to host those models. And so the Filecoin ecosystem seems to be perfectly poised, at least in his mind, that in the conflation of lots of GPUs, lots of capacious storage, and the resources to mix them all together and make that a service that can be run on demand in parallel with the rest of the activities that we have going on. Because, the ceiling operations are kind of bursty, generally speaking. And it just seems like what excited me was his level of excitement of these things coming together in ways that are unique to Filecoin.
Yeah, it's always nice when you see someone who appreciates what the network brings to the table in a way that perhaps could be viewed as underappreciated. So I agree.